I have been using a 40 10 meter inverted V dipole antenna for several months now. Earlier, I used to get good performance on both bands. Now, I am not getting much on 10 meter band, though I am not sure whether it is due to the problem of antenna or band conditions. 40 meter performance is still good for local contacts. 40 meter elements also function fairly well for 15 meter as third harmonic. I have been spotted on reverse beacon network for both 40 meter and 15 meter from Delta, Florida to Charlie Kilo at 4,400 miles with signal to noise ratio of 11 and 12 decibels respectively. Though I tried several times, I have not been spotted on 10 meter yet. So I decided to bring down the antenna to have a look. Along with that, I thought of converting it to a fan dipole for 40, 20 and 10 meter bands with 3 sets of elements. Currently, I do not have an antenna for 20 meter as I had to dismantle my N-fed half-wave dipole antenna for 20-10 meter to mount my experimental 80-20 meter loaded coil dipole antenna, which is yet to become fully functional. Fan dipole antenna can be implemented in 2 different ways. The installation which I had brought down had the elements mounted separately at an angle. Though the 40 and 10 meter elements were supposed to be at right angles to each other, due to lack of suitable supports, the angle between the elements was not as suggested. The apex angle of 2 dipoles were also different for the same reason. The 10 meter elements were at an acute angle, which is not an ideal way to mount an inverted V dipole. Still, I was getting SWR in the tunable range for my FT710 radio, though not below 1.5 on 40, 15 and 10 meter bands. Incidentally, I could work 1 or 2 contacts through the cross-band repeater on International Space Station VHF UHF using this antenna, possibly resonating at very high odd harmonics. If more dipoles have to be added to this type of installation, they will be almost in a cone type pattern with angles between the elements for different bands. But now I wish to try the more common type of mounting for fan dipole antennas, which require only 1 central support and 2 side supports. That is by having the elements parallel to one another at a spacing in a vertical plane. All the dipoles will join together near the feed point like a fan and then be connected to the 1:1 current balance which I have at the feed point. Purpose of the 1:1 current balance is to match balanced dipole antennas to the unbalanced coaxial cable transmission line. Coaxial cable, though having only 2 conducting elements, the shield will have an additional unbalanced current on the outer aspect in addition to one on the inner aspect. The former is known as common mode current. Ideally, you need a common mode choke or line isolator, typically made of coax wound on a former or air core, which I do not have currently. It is rather difficult to wind my RG213 feed line in the form of the so-called ugly balun. If it was RG8, it would have been easier. The unbalanced current can bring radio frequency energy down to the shack and cause radio frequency interference with the equipment there. Part of this can also be taken care of by good grounding of the outer conductor of the coax at the radio end, or better still, on entrance to the shack. I had implemented the latter type of grounding for my N-fed half-wave dipole antenna. Other considerations while constructing this type of fan dipole are the type of wires to be used for each of the elements. Currently I am using 2.5 square millimeter insulated copper wire for both 40 and 10 meter elements. It has been suggested that the longest element has to be of the thickest wire, as it has to bear the weight of other elements. This problem is more for horizontal fan dipoles, which can significantly sag with the weight of multiple elements and the spacers used to keep the elements apart. In my case, I plan to use the current wires as such and add a set of 20 meter elements with 1.5 square millimeter wires, as that is what I have in surplus. The downside of using thinner wires is the reduced bandwidth on that band. Tuning will be more difficult when I add one more set of elements, as the elements will certainly interact with each other, though the principle is that each will resonate only at their frequency and present high impedance at feed point at other frequencies. The only exception is if you add elements for odd harmonics like 40 meter and 15 meter or 80 meter and 30 meter. Odd harmonics will present low impedance at the feed point, and that is the reason why we can use 40 meter antenna for 15 meter and 80 meter antenna for 30 meter. But in my case that will not be an issue, as I am planning 40, 20 and 10 meter only. There are people who have added more bands and found tuning extremely difficult, though achievable with a lot of effort. I am planning to use pieces of surplus electrical wiring PVC channels for the spacers to keep multi-band elements apart.